Hello, today we will discuss quasiquotation. So let's get started. So as I told you in the previous video that everything a symbol for our evaluator, everything means keyword is also a symbol, operator is also a symbol, and identifier is also a symbol for our evaluator. And all the symbol eval what they refer to, and all the data structure eval themselves. And so our evaluator for this type of recognize this type of symbolic expression here, and first symbol must be a function or opcode, and the rest of the amount should be operands. So whenever you write this command, I am writing here sum. What he do, sum is a symbol here, right? And what he do now, he search the meaning of some symbol in the current environment, global environment in this case. And if he did not find, what he do, he goes to the stats environment here, and as you can see that he not able to find the what is the meaning of some symbol here. So now what he do now, he goes to the base environment, and as you can see that we got the meaning of some symbol, and now he returned to the meaning of some symbol to the user here. So we got function. So this is the basic approach of evaluation of some symbol, any symbol for the R evaluator. Now let's look this command here. When you call this function, so my fun is a function here, okay, and my fun I am giving a value x equal to 3. So now in the current environment, my fun x is pointing to the 3 object, okay, and when you run this command, and as I told, so y equal to 2 here already, he automatically fetch here because he have to evaluate the x plus y plus 1. So he able to evaluate the x here because x is equal to 3 here and y is 2 here. So x means 3 plus 2 plus 1, that will give you 6 result, okay. But what happens if you give this command here, my fun x equal to 3 and y equal to y, you can write this symbolic expression like this also, my fun 3 and y, this is the same things, okay. So when you call this command, what happens that he able to find the value x equal to 3 in the current environment, but he has to find the meaning of y symbol so that he can assign the y symbol to the y, okay. So now what he do, our evaluator, to search the meaning of y, he goes to the global environment, previous environment, and he able to find the value of y here, that is 13. So x means 3 here, 3 plus 13 16 plus 1 17, so that should return a 17 here, and it returns 17. What will happen if you didn't create any y variable? And so when you run this command, what happens that as previous, he goes to the global environment to the meaning, to search the meaning of y. So as you can see that global environment is empty, there is no definition of y here. So he goes to the stats environment is also empty, and he goes to the graphics environment and empty environment, and he did not find y. So he complained that y object I am not found. So this type of error he will give. Now let's look the tidyverse function. So I am using here select function, and as you can see that y is a symbol here, so he should go to the global environment to search the meaning of y here. But when you run this command, what happens that it gives you result. By the previous example, our evaluator should go to the global environment first to the find the meaning of y symbol, then stats environment, graphics environment, and empty environment. But in this case, in the tidyverse case, he did not, because we stop the R evaluator from the evaluation. Okay, and we see in all the tidyverse function here, like select function, group by, mutate. In fact, all the tidyverse function works like that. And you can see in the base r also like library is a function, and we give here plotly is a symbol here. Okay, and this is the dollar function we do because we capture the argument of the function here and we execute the tidyverse. So first of all, tidyverse is not only execute in the R environment, R system. Okay, he execute in the R interpreter as well. Tidyverse command also execute in the arrow system. He also execute in the dplyr system, and he also execute in the spark system. And to make this type of ecosystem, we have to capture the argument. Without capturing the argument, it is impossible. Now let's see, this is the data frame and I want to write like this. We can do by this function here. So I am using here base R functionalities and I am capturing the argument by the substitute function here. Now let's come to the quasi-quotation. Suppose a scenario here. I want to divide x by y, and y is a very complex formula. Let us imagine, or a normal variable that I wrote in the global environment, and unfortunately y is also a name of a column of a df. Okay, so I am creating a new column here. As you can see in the slide, mutate nn is I'm creating a new column here, nn, which is I'm assigning x divided by y. When you run this command, what happens that it gives you this result, and this is basically this. So 1 divided by 4. So 1 is fetched from the df's x column, and 4 is 4 value fetched from y's column of df. So 1 divided by 4, 0.25, 2 divided by 5, 0.40, and 3 divided by 6, 0.50. But I want to divide this x by the 13, which is available in the global environment. As you can see, 13. So to do that, we have a bang operator. So bang operator, what he do, he send the R evaluator to the global environment. Okay, in any environment. Basically we unquote the R evaluator. Okay, now he behaves like a normal evaluation. So I am writing here nn equal to x divided by bang y. That means that now he able to go in the global environment and he got the value 13. So now he able to calculate this, which is basically a 13. So 13 is a global environment. Okay, and that is things I want. So this is the R studio, and I am making a variable here y equal to 13, and this is my function here. And when I eval it, we will got 17 here. Now I am creating here a data frame. So this is the select function. It is very similar to the tidyverse, but it has only one use case. This is a function, and when you use this function, we got 1 2 3. That means that we got x value here 1 2 3. We can also get y here. So 4 5 6 is the y column. So it works similar like a tidyverse. Now what I am creating here, I am convert this command, right, this command into a SQL. So this is the SQL translator. So this is a select SQL command. We can also use pipe operator here. So this is the same. You can also use with the dataset as well. And we can send this command, SQL command, to the database, and so this same syntax representation we can convert into different things, right? We can convert it into this SQL, right? And you can convert this same syntax representation to the different system, and that is the aim of tidyverse ecosystem. So this is a very complex formula here, and I want to divide. Now what I am doing here, I run without a bang operator. When you run this command, it will give you 0.25, 0.40, 0.50. So that is basically 1 divided by 4, 2 divided by 5, and 3 divided by 6. This gives me the result, and I don't want this type of things, and these things I don't want. So now I am using here bang operator, and we finally got our desirable result. So that is the use case of bang operator. Thank you.